Hello, everyone, and welcome back. Uh, we're near the end of the course, so we are in our final week. And so, consequently, I wanted to use this week to delve deeper into some topics that I think would be beneficial with respect to both taking future math courses, but also just because I thought it'd be just useful to know as well, and like for outside of life as well. And so we're having a look at the Best Buy, and this was the idea of unit rate. And so recall that with respect to unit rate, this is the idea of we want to take our money and divide it by the item. And this is going to tell us the price. And what this will be equal to is the price per one item. Okay, this is what unit rate is. And it's a nice way to compare the price of items. And so we had already had a look at this previously near the beginning of the course where we set a unit rate, but we also had a look at this within the context of fuel efficiency with respect to gas. But now we're going to be specifically looking at the idea of comparing between two or more items to see what we should be spending our money on and also apply some discounts and such. And so let us have a look. So suppose we have Mrs. Caldwell and they're looking to buy food at Walmart today. She was looking to buy IM's Hairball Care formula and had a choice of two size packages. We have package 1 that is going to be $8.49 for 1.41 kg and $15.49 for 2.0 kg. So she took out her phone and did a quick calculation before choosing which to buy. Which package should she buy? And so when we think about this, we want to make a note for ourselves. We are looking to spend the least amount of money possible, assuming the options are equal. So what do I mean by that? Well, in this case, it happens to be the same particular brand of IAMS, some sort of cat food, right? And so if it's the same brand of cat food, then the two options are equal in the sense if you get the bigger bag or the smaller bag. In this case, that's what I mean by assuming the options are equal, meaning you like them equally, which makes sense for us. It's also worth noting, and I'm going to put an asterisk here. Oftentimes, the larger volume is usually the better rate. This is not always true, but oftentimes it is. So if you just care about quantity, for the most part, it tends to be when you buy the larger item, it tends to be a better sale. And it should also be aware that in stores across Ontario, the unit rate should be listed on here, but the numbers might be tiny for us to read. So if the worker forgot to put the numbers on the price item. So usually the unit rate should be available for you. But again, the point of this is we're assuming that this isn't here for you. Okay, so what do we do here? Okay, and so for our option 1, we have this $8.49 for 1.41. And so we want to take our money, which is going to be 8.49, and we want to invoke the old division sign. So remember, symbol division, 1.41. Okay, kilograms. And remember, the reason why we do this is because for unit rate, we take money divided by the item, and that gives us the price per one item. So in this case, we're talking the price per 1 kilogram. And so if we take our 8.49 division sign 1.41, we're going to end up with the 602 number after rounding. Not a very pleasant decimal, but we'll take 2 decimal places because we're dealing in money. So this is 6.02 dollars for 1 kilogram. And so now we want to compare it against the second item to see if this is any cheaper or not. And so we'll work in a little bit of a different color just so we can easily tell the difference between these or differentiate. So we'll put this in blue. And so we want to take our 15.49 and divide this by 2.4 kilograms, 15.49 divided by 2.4, and you're going to get this number. So the 645 number. And so, and again, we say this is 645 per kilogram, and we should be polite and indicate our units, so that way we have, we can easily tell the difference. Okay, so now we have a look at our answers. Actually, as it turns out, the smaller bag was the better price. And so in this case, who is this? Mrs. Caldwell? Mrs. Caldwell should buy the smaller package. Now, I said that earlier that oftentimes the larger volume is usually the better rate. The reason why this might not be the case is sometimes there comes some sort of sale, and this one could have had a sale as well, or sometimes the company just markets it that way anyways. Okay, and so in this case, if you don't care, like if you don't mind the volume of things, she should be buying the smaller one in this case. All right, and so let's have a look at example 2. So suppose a case of Coke, like Coca-Cola Pop, sells for $12.99 for 24 cans. What is the cost per can? So this is a question we've looked at previously, but again, it's a good review. So remember, for the unit rate, you want to take the price and divide it by the item. And so this is going to be, in this case, this $12.99 divided by 24. So it's going to be the 0.54 cents, otherwise known as 54 cents for 1 can. And if you notice, this is much cheaper than if you were to go to the store. So typically when you go to the store, they often would sell a can of pop from usually like $2 more or so more. And so if you're interested in buying Coca-Cola or what have you in this case, it's correct to say that you should buy a case of 24 if you're interested in drinking all of that Coca-Cola, because you're only paying 54 cents a can, as opposed to like if you go to the store, it could be $3 or $4 per can, depending on where you are. Okay. And so for example 3, I have which is the best buy. And here I have 4 different weights to work with. Now, there is one little caveat here. We've got this 500 grams for 75 cents, 1 kilogram for $1.40, 1.5 kilograms for $1.95, and 2 kilograms for $2.70. And it's worth noting here for this one that we want to make sure we're in the same unit. And so for unit rate, or I should make a little note and say for unit rate, we want to compare using the same units. Okay, and so what do we have here? Well, the only thing we need to be aware of though is, and again, we're actually going to cover this in the lesson of next time, that there is 1,000 grams is equal to 1 kilogram. And so for our purposes here, 500 grams is the same thing as 0.5 kilograms at 0.75 or 75 cents. And so this is something that we're going to need to look at on the future. This is a topic we're going to look at more closely later. Okay, so let's go get the unit rates. And so this follows the same thing. We take our price divided by item. And so here, I'll copy down the formula that we're using. And I'll put this in, let's work in blue, I suppose. Okay, and so this is going to be the 75 cents divided by 0.5. And this is going to give us 1.5. So if you were to take 0.75 divided by 0.5, that's going to give us 150. So this is 150 per 1 kilogram. Now you might be thinking, hey, we started off with a smaller number here. This was 75 cents and that grew to be $1.50. This is true. But keep in mind here, we were talking about 0.5 kilograms. This is smaller. 0.5 is smaller than 1. And so we want to compare based on 1 unit. And we're in the case, this unit is 1 kilogram. So to compare this, this number actually goes up in this instance. Whereas for these other ones, it'll tend to go down. Now, for 1 kilogram sugar at 1.40, this is actually the unit rate already. So this is going to be $1.40 for 1 kilogram. $1.95 divided by 1.5. 1.95 divided by 1.5. This is going to be 1.3. So this is 1.30 for 1 kilogram. And the last one here is going to be this 2 kg for $2.70. And so we want to take our $2.70 and divide it by 2. And so if you were to take your 270 and divide it by 2, you get $1.35. And this is for 1 kilogram. Okay. And so here, this is all of the comparisons. So we've got this 150, 140, 130, and this 135. And so actually, as it turns out, the cheapest rate is going to be this 1.5 kilograms. And so we would say here that the cheapest rate will be $1.30 per kilogram. Which was given by this 1.5 kg sugar at $1.95. Okay, that's what we're saying the cheapest one is going to be. Lastly, but not leastly, here we have the Toronto Zoo. It has a general admission price of $28 and children's admission for $18. There's also a parking fee of $10. A 2-year membership at the zoo for a family is $370, which includes parking. How many times would a family with 2 adults and 2 children need to visit the zoo in order to make it worth buying a membership? Interesting. Okay, let us have a look at this. Now, it's worth noting, if you're not sure how to start this kind of question, the easiest way for me to think about it is, well, what is the price of one trip? How does it compare to the 2-year membership? And so remember, we had to look at this kind of question with respect to transportation using the GO train and such. So how do these things compare? So it's a similar kind of scenario. Now, if I were to ask you, hey, if the family only intends on going once, should they buy the day passes or should they get the 2-year pass? And you'd be like, well, it's the 2-year. Like I can see $370 is way more than this 28 and 18 thing. So clearly, if they plan on going once, they should just buy general admission. Okay, and so let us see how this works. So some helper questions for us are, what is the price of one trip? Okay, well, for one trip, this is going to be what? Well, the family has 2 adults and 2 children, and presumably they're all going, which would make sense. So for the adult passes or adult admission, this was this general admission, right? Because there's general and children. So an adult admission, I guess we should say general admission instead. General. So this will be 2 times 28. So this is going to be $56. The children's admission, there's two of them, right? So it'll be 2 times 18. Oftentimes, a children's pass is going to be cheaper than a general admission. Okay, and so here, if we were to take our 2 times 18, that's going to give us $36. And we got to pay for parking, right? So presumably, like they're not taking, you can't get here by GO train, or you probably don't want a taxi here. So apparently, this particular family drove here, and so we have a parking fee of $10. Okay, so the one trip total, and we don't need to pay the parking fee twice in a trip, right? You just park your car for the day or however long you're going to be there for. It's just $10. So this is going to be $56 plus sign $36 plus sign $10. So we can add these together at high speeds. So 56.00 plus sign 36 plus sign 10 is going to be 102. For a one trip. All right, and that's what we got. That's what we have here then, all right? And so clearly, or I should say reasonably say, we showed, okay, well, if they go for one trip, they should pay 102 instead of 370. What about two trips? Well, if we take our 102 times 2, that's going to be $204. And so the easier way to think about this is what we can do is divide the 2-year pass price by the cost of one trip. We did the same kind of thing when we were doing the GO train analysis. And so here we're going to take our $370 and we're going to division sign this 102. So what happens when we do this? Well, 370 division sign 102 is going to be this 3.62 number. And so here we're going to put this 3.62 trips. And so we can't have 3.62 trips. We must round up for trips. And so if the family plans on going 4 times, four or more times, they should purchase the 2-year membership. Okay. So I should say, if the family plans on going 4 or more times in 2 years, they should then purchase the family membership pack.